Okay, what about integration? And one of the hard things about this chapter is keeping separate when we need to differentiate, like these two problems, and then when we need to integrate, like it's telling us here. So let's try to go the other way. Let's try to integrate an exponential function like 2 to the x. So if differentiating involves the chain rule, that integrating is going to involve u substitution. So integral, indefinite integral, because there's no bounds on this one, 2 to the x dx. I'm going to start, same way I started the other one, by rewriting the 2 as e to the ln 2, raising that to the x power. And then I'm going to write that as e to the ln 2 times x. All I was doing was just using that property of exponents that multiplies these two, right? ln 2 is a number times x, right? And then I realize I've got a function inside of another function, so I'm going to use u substitution. And my u here is ln 2 times x. And I'm going to remember, this isn't the chain rule, this is u substitution, so my next step here would be to replace this with its new name, which is u. Just rewrite the integral. Now the problem is that we got this dx here, so if you remember how we get rid of that is we find our du dx, which in this case is just ln 2. It's just we had a constant times x, so the derivative is just the constant ln 2. And then shuffle this around, solve for dx, we get du over ln 2. So I can rewrite this as e to the u times du over ln 2. ln 2 might look weird, but it's just a constant, so we can pull it out just like any other constant. Got 1 over ln 2 times this antiderivative, which is pretty simple at this point. Remember, e to the u, the antiderivative is just e to the u plus c. And then we can we multiply it by this constant here, right? Almost done. Next step, replace the u with what it's equal to. U is equal to ln 2 times x, so we've got it's 1 over ln 2 times e to the ln 2 times x plus c. And the last step again is this step of just kind of simplifying this, writing this in a better way, changing, if we have to remember to put the u, replace u with what it actually was, we also want to replace rewrite it as the base it gave us. It didn't give us base e, even though this is an acceptable answer, or it's a correct answer. What we want, it would only be polite, let's say, to write it in the base that they gave us, which was 2. So let's scroll down to here. I'm going to write this as 1 over ln 2 times 2 to the x plus c. There's your antiderivative. And if you compare that with the formula that they sort of generalize from it, I don't know if I can get them both on the screen, but there we go. The antiderivative of a to the x dx is 1 over ln a times a to the x plus c. So, this was it for this was the antiderivative for 2 to the x, but in general, it's going to look like this. Like I said, I wouldn't recommend trying to memorize these formulas. I think it's better to work through the chain rule or use substitution in this case, and get it that way. Okay. Okay, now let's look at. Actually, let me take a break, and then I'll start again here in a second.